In this segment, we'll explore some of the impacts that past droughts have had on human societies. Like India, China is also vulnerable to drought, as it relies on monsoon rains for much of its moisture. If something alters the monsoonal pattern, then droughts can plague China. 9.5 million people died in China as a result of a drought that occurred in 1877 to 1878, which was the same time the drought killed another 5 million in India. 3 million more died in China in a drought that lasted from 1928 to 1930, but those deaths were completely eclipsed by a huge flood in 1931 that killed nearly 4 million people. However, for a really big disaster, you often need to add in a human component. And China had one in Chairman Mao's Great Leap Forward, which was one of the largest attempts to transform a society in history. Its goal was to move many people from farms to cities in an effort to quickly transform China from an agriculturally dominated society into a more modern industrial nation. Unfortunately, that effort coincided with one of the worst droughts in China's recent history, so the reduction in farmers combined with drought conditions led to widespread famine, which resulted in at least 36 to 45 million deaths, and greatly reduced birth rates. In a remarkable understatement, those years are now referred to in China as the difficult 3-year period. If direct deaths, indirect deaths, and decreased birth rates are all summed together, the total population loss may have been as high as 75 to 85 million, which is more than the current population of the United Kingdom, France, or Germany. I was born in the 1950s and remember my parents, as well as those of my friends, telling us to eat all the food on our plates because children were starving in China. At the time, I only wondered how my eating in any way helped to alleviate that condition. As a child, I never questioned why children were starving elsewhere. Only later did I learn it was a result of human politics amplifying the impacts of a natural drought. Droughts, whether natural or human-induced, have many secondary impacts as well, including wildfires, as drought dries the landscape, transforming vegetation and falling branches into tinder. So it's no coincidence that wildfires increase in both size and number as landscapes dry out. And it's not only forests and woodlands that burn, but homes that lie in the fire's path. Drought can also greatly reduce water flow in rivers, which allows saltwater to seep into coastal areas, killing vegetation and damaging coastal ecosystems. While in other areas, droughts can weaken crops and natural vegetation, making them more susceptible to diseases or insect infestations. Like this pine forest, large parts of which have been devastated by pine beetles. With decreased vegetation and soil moisture, dry landscapes also suffer more wind erosion, which can lead to dust storms, which not only reduce visibility, but also reduce sunlight, and hence plant growth, and can even lead to car accidents because of hazy conditions. Dust in the atmosphere can also lead to engine failures and even significant health issues, because it's not only dust that's transported in the air, but many harmful pollutants, as well as bacteria and fungi. And dust plumes can have global, not just regional effects. As an example, Caribbean reefs are harmed by Sahara dust. But from a human perspective, the greatest impact of those dust storms may well be the loss of soil, with the consequent loss of agricultural productivity. Now, although not all droughts are associated with heat waves, for those that are, the high temperatures alone can be a significant risk. Often because people underestimate the temperature's impacts, especially in populations who are not used to extreme temperatures. In Minnesota, we're familiar with winter cold, so we generally do a very good job of preparing for it. But we're not as experienced in dealing with the risks of high temperatures, which are heat stroke and dehydration, so we fall prey to those more easily. But high temperatures also accelerate chemical reactions that produce ground-level ozone and smog, which are also significant health risks. Remember that high temperatures do not equate to dryness, which is important because the main way that humans lose excess heat is by sweating. So high temperatures combined with high humidity can be much worse, as high humidity diminishes our body's ability to reduce body temperature through perspiration. And we can only sweat like this in Hollywood comedies, not in real life. This is one of the canyons in the Guadalupe Mountains where I did a lot of field work when I was younger. Temperatures in the open air sometimes rose over 120 degrees Fahrenheit, and they were even higher in the canyons as heat radiated off the rock walls. So at times the heat was brutal, but at least it was dry heat, which made it easier to handle. Back in Minnesota, we have much more humidity. And if humidity is 80%, temperatures of 95 degrees Fahrenheit can have the same impact on humans as a 133-degree temperature would have in the dry Guadalupe Mountains. Yet people often do not pay as much attention to that heat as they would if their thermometer actually read 133 degrees. Urban areas are particularly vulnerable to heat, as their dark-colored infrastructure absorbs solar energy more effectively, as do the many particles in the air which come from vehicle exhaust or industrial smokestacks, which can increase to the point that the particles alone, much less their additional heat, pose health risks. The combination of particles and infrastructure density can produce a heat island effect, which can raise temperatures in the city up to 5 degrees Celsius higher than over the adjacent countryside. And you can see that heat island effect in satellite images of a city that show the city in visible light and ones that measure the ground surface's infrared heat. In the lower image, you can basically map out the city simply by following the heat signal of its infrastructure. And that's true of most cities, whose heat island effects clearly show up in infrared images. But in our modern society, we use fans and air conditioning to offset some of that heat. So the resulting high energy demands can overwhelm our power grid to result in outages. In the United States, more people die from heat than floods, hurricanes, or any other natural hazard. Despite all of our technology, heat still kills, which is something that shocked us as a nation when a heat wave in Chicago killed up to 700 people. You can read about this event in Eric Klinenberg's Heat Wave. Well, why did this heat wave result in so many deaths? Ironically, air conditioning played an indirect role. At the time, most people, including those in government positions, had air conditioning. So they simply did not realize how hard the heat was on poorer people who lived in housing that lacked any effective way to cool down. So they didn't respond to the heat wave as quickly as they should have. But changes in society also played a role. During earlier heat waves, families tended to live close together so they could keep tabs on one another. When it became brutally hot, many families simply slept overnight in city parks to keep cool. But by 1995, we tended to live in more isolation, and a fear of crime led many people, especially elderly people who lived alone, to stay out of parks and to keep their windows closed and locked. As a result, many of them died from the heat. America was shocked to see images of bodies stored in refrigerated trucks as morgues were overwhelmed, and to learn that mass burials of unclaimed dead could still happen in America. But the United States is not the only industrial country that found itself struggling to cope with heat waves. In August of 2003, Europe found itself suffering through temperatures that were 8 to 10 degrees Celsius higher than normal. And despite its wealth and technology, over 35,000 of its citizens died, with nearly 15,000 in France alone. And as bad as those estimates were, a more recent review of excess deaths places the total at over 70,000. The heat returned in 2006. And although this map looks much worse than the last one, the color scale here only covers half the temperature range that the previous map did. So this heat wave was not as bad. Yet it still resulted in the loss of 3,400 lives. Another heat wave in July and August of 2010 left the landscape of Russia and Eastern Europe dry and parched, resulting in hundreds of wildfires. In many places, temperatures during this heat wave were over 12 degrees Celsius higher than average. So while the 1995 heat wave in Chicago killed up to 700 people over its whole duration, in Moscow alone, an average of 700 people died each day. And across the whole region, heat killed over 55,000 people. In Moscow, the air was so bad that it was the equivalent of breathing cigarette smoke all day long. Yet heat waves like this are likely to happen more often in the future as our climate warms. Until recently, the hottest year on record was 1997, until 1998 set a new record, followed by yet more new records in 2005, 2010, 2014, and 2015, when heat waves in Pakistan and India each claimed 2,500 dead. And as I record this, 2016 is on track to be the hottest year ever. But even if this year fails to set a new record, the pattern of increasing warmth as climate changes means that heat and drought will continue to pose threats. And since warm air can hold more moisture or water vapor than cool air, an increase in temperature as the climate warms can result in both more precipitation, which in turn means more flooding, as well as more evaporation to lead to more droughts. So basically, a warmer climate means that extreme weather events are more likely to occur. While the public discussion on climate change often focuses on water components, such as flooding, rising sea levels, and more powerful storm surges, desertification, drought, and heat waves are just as likely to be significant threats to our future. They are still water issues, but in terms of diminished water supply. With rising temperatures, water scarcity and water excess will both occur. Well, before we explore future climate change, let's first step back a bit to consider past climate change, which was first widely recognized when people realized that the Earth had gone through ice ages. The recognition of those ice ages will be the subject of our next segment.